know that. It's really important to know which is the explanatory, which is the response. If you do change those, we would have completely different slope and intercept. Okay. Regression fact number 2. There is a close connection between the correlation and the slope. So we could rewrite this. We could rewrite this here as a function of r is equal to b times the standard deviation of the x's divided by the standard deviation of the y's in the denominator. So the slope is basically r, correlation r, times the standard deviation of the y's divided by the standard deviation of the x. And then the correlate, it can be rewritten. So I'm rewriting it using algebra. I'm just bringing the r to the left and the slope to the right, and then the standard deviations for y will be in the denominator instead of the numerator. So this, if you know, this is good to know, because if you have these values, you probably would agree with me that if you have, let's say, the slope, right? You have the slope and you have the standard deviations. You would agree with me, this would be a lot easier to calculate the correlation than what we just did at the end of chapter 4. Right? What we just did at the end of chapter 4 was a long, even with just 5 pairs, XY pairs, long, took us a little bit to calculate, right? But if we just have a slope and the standard deviations, 3 numbers, and you would have your correlation. So it depends on the question and what you already have calculated. Okay. If you already have, if you're being, it depends what you're being given in the question. Okay. The slope b and correlation r always have the same sign. So if they're both if the slope is positive, then the correlation must be positive. If the correlation is negative, then the slope must be negative, and vice versa, right? They have to have the same sign. And a change of 1 standard deviation of x corresponds to a change of r standard deviations in y. Okay, regression fact number 3. The least squares regression line always passes through the average. And this is a great way to know if you have calculated it correctly. And we'll see that at the with the example we used with the online chat feature. We will calculate the means. We will calculate the regression line at the end of the chapter, and then we will sub in the mean, and we should get the mean of y as the output. So just to show you this is whatever the average is. Let's suppose the average NEA, non-exercise activity, was 400. Let's say the average from the data was 400. Then the average y should be 2.145. And it would be, and it has to lie exactly on the line like that. Okay, that's an example. The XY pair must be, and the line always passes through it. So that's a way to check if you've calculated the regression line correctly. Regression fact number 4, the correlation R describes the strength of a straight line relationship. And we saw that the closer it is to +1 or -1, the stronger the correlation. The closer R is to 0, the weaker the association.